Imagine if you got the orientation data, the IJK vectors for the upper arm and forearm for every frame of data from a motion capture machine. So now reconstruct the movement. The animations are usually stored in the computer as individual files. They are text files that store the vertices and faces. One joint center is usually at 0, and the other is at 0, 1. Let's check the orientation of the humerus. The distal center is at 0, while the proximal joint center is at 0, 1. For the radius, it's the same too. The distal at 0, and the proximal at 0, 1. We can scale it by multiplying the vertices by some coefficient. Let's save these vertices in the user data property of the patch. Right now, we'll assume that the shoulder joint does not move. To reconstruct the movement, we will do the following algorithm. 1. Get the original vertices and faces of the humerus and radius. You'll find them in those text files I've been talking about. 2. Add the location of the joint centers, 0, and 0, 1. 3. Scale the vertices to the desired length by multiplying by some coefficient. 4. Get the orientation of the humerus. We'll call it H-ort. 5. Transform the vertices out of that nested H-ort system into the global system using C-transform. 6. Displace the humerus to align the proximal joint of the humerus to the shoulder joint center, a randomly chosen fixed location. Here we have to use vector subtraction. The shoulder joint center, which is randomly chosen, minus the proximal joint center of the humerus. 7. Get the orientation of the forearm. We'll call it fore-ort. 8. Transform the vertices out of the nested fore-ort system into the global system using C-transform. 9. Get the position of the elbow by the last vertex from the upper arm. 10. Displace the forearm to align the elbow joint center to the radius's proximal joint. We will use the same vector subtraction. The elbow joint XYZ location minus the proximal radius joint center. And finally, number 11, repeat these steps for each frame of data. Here is the algorithm in action.